Hello, hello, hello. Hi Thorfinn, how are you? I have some good news for you. I made that DUI finally. But I have some bad news as well. So, let's see. Okay, make is done. As you can see, warnings have exploded. Let's run this. And there you go. There is the TUI. This TUI does not do much. It just captures all any yeah, hope you can see. So basically this is the TUI part, right? And whatever key you press, for example, if I pressed let's say P, it will send it to the server, and the server will then send the text. Um, but I have realized something which came as a shock to me. Okay, so C does not have a good SSH ecosystem. Yeah, there, I said it. I tried so much to get this TUI to figure out the size of the terminal, but I could not. And this finding the size of the terminal is absolutely essential for us. I'll tell you why. You might laugh at it, but it is true. Anyway, so we do new vim. Yeah, let's find a file, our server file. Now let's find change. Yeah, let me do this. First of all, as you can see, all of the functions are deprecated. Fun part is that the replacement for these functions have not been published in the library. Just wow. Like, how does that even happen? I have no idea. Second, if a SSH application changes its size, if a client changes its size, there is no way in this library for us to know if the size has changed or not. Yeah, I know. Shocker. Actual shocker. I tried importing everything I knew would work. Nothing worked at all. And it was just disappointing. That is what it was. Extremely, extremely disappointing. So last night I had a choice of just continuing and implementing SSH on my own. But then I asked the right question. Why is there no good SSH libraries for C? Meanwhile, we have a lot of SSH libraries for Golang, Rust, and what have you. I was wondering, I was very curious about what happened, right? And the answer that I got was that no one really wants to implement SSH in C. People are like crazy afraid of fucking up the security. And yeah, that is literally what's happening in SSHC world. So the other question I had in front of me was, what should I do? And after a lot of thought, I asked myself, why am I so married to the idea of writing this application in C? You know, I've never been very attached to any particular programming language. I thought of C because I wanted to learn it for future goals I have, that is kernel development, and yeah, write SSH in Go or Rust. Hmm. But that doesn't serve my purpose, right? I want to learn C and I want to learn C really well. So, after a lot of consideration, I am abandoning the project. I don't want to do it. It's literally just fighting against uh, years of convention and SSH people just moving forward. I know, but think about it. I want to learn C, and the project I'm working on is not really does not have a, does not really have a lot of support in C. So now I was thinking, if I'm not doing C, what should I do? If not C, what do I do? And I had no idea. I don't want to learn Go. I already programmed in it. I am fairly proficient in Go, fairly proficient in Rust. C is what I wanted to learn. So I didn't think much, and I've gathered a few ideas, okay, and I want to run them past someone. I want to run them past someone. So first idea that I have to learn C. So what really happens in C? What gets made for C? Right? Let's say what development is active in C. And I realized that it's a systems programming language, and I want to prepare for it, so I might as well do it. Does that make sense to you? Then I found out about this very interesting thing called Chip8. So what Chip8 is basically, oh, you know what Chip8? All right, okay. So Chip8 is as you can see, it's an interpreted programming language, right? Made specifically for 1802 microprocessor, right? So something like this. I mean, a lot of parts here are modernized, for example, the keyboard and all. But it's a very old machine, works on a um, very simple formula, so to speak, right? Not a lot of instructions, only these instructions are there. Nothing much, right? So what I want to do now is make an emulator for it. Make an emulator for it. So what do you think about it? So this interpretive language has 35 operation codes, okay? So um, let's see. First idea is chip 8 emulator, right? This is idea number one. Second was to make a REPL, right? You know what a REPL is, right? Like how when we do, let's say when we do Python, I don't know if I have Python installed. Yeah, when we do Python, so exactly you can do whatever, and then it will just read your code, evaluate it, and print the result. So I was thinking I want to learn C, and I could just make a REPL which would it will be like an interpreter for C language. So what do you think about that? So this is idea number 2. What else happens in C? I was wondering. And then I thought, hey, ZSH is written in C. Okay, if we see, okay, it's mostly shell. My bad. No, this is oh my ZSH. Wait, no, I want ZSH. Do you know what ZSH is? It's a shell. It's a default shell in macOS. Yeah. So I was thinking this is written in C and a weird language called ROF. I don't know what ROF is. Okay, my PC hanged. Why? Okay, ROF, yeah. It's a typesetting markup language, whatever. Right. Then I search for new shell. And it is written in Rust, I think. Yeah, Rust. And more as I looked at more shells, I figured out this is a very good use case for a systems programming language. So third idea is writing a shell. So the question now is, which one should I do? Let's write pros and cons, okay? Chip 8 emulator, super easy. Very fun though. You can play games on it. Right? C interpreter, it's a super stupid idea which I have blatantly copied from this guy, which I keep talking about. His name is, YouTube channel is Soding. Yeah, this guy, right here. So if you search for Soding, C interpreter, okay, he has not made it, but I got the idea from him. Okay, so like a REPL which can evaluate C code. Super stupid idea, love it. So it can also be really fun. It can help us in future to test out other libraries without actually installing them or adding them to our code. And then shell. Solved problem. I will learn a lot about Linux. So, since you're my only regular viewer, I want to give you the opportunity of voting for it. We'll both go on a vote. Okay, so I will vote something, and you vote something, and let's give them a quote. Yeah, DPPP is not here. Okay, so this is this is voting. Okay, I now how do I create a vote? Yeah, I don't trust this website actually. Now that I think of it. So on a count of three, we both will vote. Okay, first you vote because there is delay between my voice and my text. So vote. Vote now, Thorfinn. 0, 1 or 2. What do you want to do? Let's go! I wanted to do it so bad. Oh man, okay. This strategy of mine has come fruitful. Okay, very nice. No second vote. We are going to make a shell. I'm extremely excited, okay? Perfect. Okay, beautiful. So how do you write how do you write a shell? Answer is I don't know. So what we can do is look at POSIX standard for POSIX standard for a shell. Okay, and then take it from there. Let's do a basic search. Is there a standard for shell? Uh, Linux shells. Oh, there are 8 types of Linux shell. I had no idea. What the fuck? Okay, no, these are just different shells. Okay, this is fine. All right. Okay. God, I can't back it without. Holy shit! Can I go back? Okay, fuck you. Okay, Linux has something for us. The process of identifying a single GNU Linux shell as standard requires that feature intrinsic to the shell be analyzed alongside attributes. Blah 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 blah. Okay. This is more of a, how do I say? It's a recommendation. We don't have to follow it one by one. But I'll try my best to stick to a standard. So All right. So first we have the POSIX shell. POSIX shell. Basically, whenever you do sh without typing anything else like bash or whatever, zsh or whatever, this is the default standard for shell. Okay. And what is this? Yeah, correct. So we can either look this up. Then what else? Then we have Bashlex shells. Basically, there is no spec for it. Okay. Uh, I want to actually make a minimal shell first, and then see if I can add features to it. Right? Okay, so I'll write down what I know about a shell. Oh, first of all, let's name it something. So can you give me some interesting project that I can build in Go? Okay. Okay. Do you want interesting and slightly more difficult? What do you think? It'll teach you channels so well that you will always be able to use it again. So what do you think? Can I give you something interesting and little challenging? Yes, let's fucking go. That's what I thought. Okay. So let me write you a little specification, okay? Wait, what do we have? We have learn. Okay, so we go to learn, and here we do something called chat. Holy shit. Okay, my humor today is crazy. Okay, chat. So it is shell chat basically. Okay, so what you'll have to do is you have to create two targets. Okay, one is going to be a shell, a server. Another is going to be a client. Okay, and you can have multiple clients. So clients might run from different terminals, different terminal windows, different terminal instances. So you'll run one server, and all the clients will then connect to the server, right? And they will create a chat room. Okay, so let's say if client 1 sends out a message called hello, then client 2, 3 and 4 will receive a hello. Okay, and then vice versa. No synchronization, no server state, nothing at all. As soon as your clients connect, they can receive and they can send messages. That's all. No authentication, nothing like that. And it all happens on a TCP, using TCP, transmission control protocol. And if you think about it, TCP is not very it can maybe send out your packets, but how to parse them, what format to send out is totally up to you, right? So I'm not asking you to implement HTTP. I'm asking you to implement it in TCP. Okay, TCP and use sockets. The challenging part is you do it only using Golang packages. You already discussed what packages are, right? So, yes. What do you think about the project? And we call it shut. There are more specifications actually. Okay, let me actually rename this. Specification. Okay, you'll have to properly create a project which has two targets, server and what do you call it, client, right? Both have to be fun to work with, right? No argument parsing or anything. Server will take maybe a port number or that's all. So I have to build a connection between server and client, of course, but how? So there are a lot of methods actually. Okay, what computer do you use? What operating system do you use? I want to know this first before I make any suggestions. Okay, so tell me OS first. Linux. What Linux? Lot of Linux in town. Don't tell me you use Arch. Don't write Arch, by the way. Holy shit! Don't do this to me. Do you use Arch, by the way? Let's fucking go. I got out Linuxed. I'm a senior software engineer. I got out Linux today on a stream by a college student. I should kill myself. Oh, should I be saying all this on YouTube? I don't know. I'll delete this part then. It's fine. Okay. Yeah, I should unalive myself. Yeah, that's the YouTube term. Anyway, so yeah, how would you do it? Okay, so you're on Linux, right? Uh, so how familiar are you with TCP? All you need to understand TCP really is look at a image like this. Okay, one user agent sends out a SYN package, then a SYN plus acknowledgement package, and then there is your connection, right? So what will happen is you'll have a server and you'll have multiple such clients, and you'll keep an open connection with all of them. And when we talk about open connection, the first thing that should come to anyone's mind is sockets. Sockets, Linux, and boom. That is something cool. Sockets. You will use sockets. And the best part is net package Golang. Yeah, so the net package in Golang already has all this implementation. Okay, all you will need to do is basically use this library to implement a connection. Okay, so your server, okay, how I would do it would be to create a socket on Linux file system socket or something. I forget the name. Linux socket for actually forget about it. Your server will accept connections. Okay, so basically you'll be able to create a socket with your server, and Then via TCP, you will send out packages with your messages, and you will receive messages from the server if someone else pings on the server. I built a P2P file sharing website and use Socket to relay the information. Yeah, same way. Same way you will use sockets to relay the messages from your clients. That is all you have to do. Nothing more. Just as an interesting thing, if you are making an application that will run two processes locally, they can also communicate via sockets, but those sockets won't be transferred on the internet. So Linux has its own Linux IPC socket. Yeah, so you can basically use a local socket to communicate between two processes. It's called IPC, internal process communication. Don't use this, of course, because your server has to wo- work with both like local and LAN clients, right? So don't use this. I'm just saying that this exists. You can open a socket and then you can interact with it as you would interact with a file in C. That's the beauty of it in Linux. Everything is a file. So you can write to it, read to it, do whatever you want with it. It's beautiful. Yeah. AF Unix, something this. I remember. If I'm not wrong, you can do. Yes. Something like this. Yes, I know this. I've worked with this. There are multiple types of socket connections you can make. Oh, I got sidetracked, by the way. I do that a lot, by the way. I get distracted very easily. Anyway, so your project will be a server which will accept socket connections, and then it will relay information to other clients. That is all you have to do. Golang, do not use any other library for this. Okay, just use net package from Golang, and I think it will be sorted. What you can do though, what I will recommend you to do is try to use channels. Okay, so yeah, make that. So as an engineer, I get asked this question a lot. How much time do you think it will take? Is this Attack on Titans? 2-3 days maybe. Okay, take 3 days. So today is what? Today is 20 January, right? Yeah, that's the fun part, right? You should not know how complex it is, okay? The next project is going to blow your socks off. So take your time. Oh, Vinland Saga. I see. So take your time. Actually, you know what? Take a bonus day. Take 4 days. We will connect on your project on 24th. What else do you have on your GitHub? Now I'm curious. Oops, practical. What is oops? Oh, object-oriented programming. Of course. There is no make file. Oh, and you added the files via upload. And you added all 7 of them together. Oh man. You know, sometimes I miss C++, but then I stop myself from using it. It's too enticing. Okay, what else? 22 repositories. Damn, dude. You're writing big projects. What the fuck? Damn, damn. It's embarrassing? Oh, brother. I'll show you my reports. They are embarrassing as fuck. Where is G? Yeah, okay. This is my repository. Look at this. Look at this. If yours were embarrassing, what do you think about this? Do you clerk? What does that mean? What word am I supposed to replace with? What word am I supposed to place no in? Know you clerk? Do know clerk? Do you know clerk? Do you know clerk? Ah, that makes sense. Okay. So is this something you're talking about? Ah, okay. No, I mean, think about it. Authentication is like a very small part of Authanoth in a big enterprise, right? I'm trying to build this. Man, do you know what they say about authentication? Never roll out your own. But you should do it, I think. As a as learn. Oh, the Authsphere one. Ah, I see. So what you're trying to do is okay, let me actually read about it, man. I guess services is where the magic happens. Ah, I see. Okay. I understand what you're doing. Hmm. 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 All right. Okay. Docs are fucked. Who cares about docs? I mean, you can just read the code, right? I think I've written very nice code actually. Some comments, function names are nice. Good man. Good job. Oh, but you're making it with someone, is it? Ah, a friend. Nice. Two contributors. I'll start it. Okay, sorry, I'll not start it. But yeah, documentation is for sure. It's nice only. You have built with love. A JS, what do you say? A JS staple. Built with love. If I search for it, what will come? Wow, there are code snippets to add one line. God, that is insane. Holy shit. It's a mini library. The idea was to make backend in Go. Why didn't you make backend in Go? That was not a bad idea. Indian engineering jobs, analytics, programming. I don't think it understand. Yeah, dude, look at this. Yeah, Golang, C++, Java, Python, JavaScript. I think, but neither of us know it. I mean, that shouldn't stop you, right? Like, you can just know it. I mean, I'm not a big fan of adding dependencies in your project, but Golang was not a bad idea actually. Let's see. Alright, dude, let's make it. What should we name this shell? Uh, you need to hit the backend URL. I mean, think about it. Since you will need to basically know the IP of the computer you're running the server on and the port of it. Nothing more. For example, my computer's IP right now is 192.168.64.8. So if I'm running a service on port 2000, then anyone on my Wi-Fi can connect to it. Alright, by the way, what should we call our shell? I was thinking something like shit shell. But do you have a better suggestion? See, we have fish, ZSH, CSH, BASH. Then we should have Ooh, Nova Shell. NS. Perfect. Nova Shell. MESH. Mesh. Ah, not a bad name. Too late though. Sorry. Nova Shell it is now. Let's see. Uh, so let's make. What the first file that you make? Main file, right? And let's do include stdlib or whatever. Let's make a function int main void then we do yeah, I think this is a good start. It's a good start. Okay, let's compile the file using I don't know, makefile. Okay, so we have all is dependent on God. Okay, this right now, then there was this weird thing, convert .c file to .o files and make file. There was a weird syntax for it. Oh yeah, this stuff, yes. Alright, okay, so what we do is we basically take objects and define it as this. Okay, these are our object files, and our object files of course depend on the sources, I guess. I mean, I can just look into how we defined yeah, I think I should probably do that. It's not cheating if you're copying yourself. Okay, we don't need this. Simple enough project. We have this. Build your own X. Okay, let's see. Build your own X shell. Let's see. This is giving away too much. Look at this. This is code. We can't copy the code, man. Yeah, I mean, this is giving a bit too much. I'm sorry, I will not use this. We'll do it the old fashioned way. Just we have pkg config. Okay, we don't need this right now. What else? We don't need a lot of it actually. We don't need this. We do need this. Don't need this. We can replace it with this, and don't need this. Or do we need this? We need this, I think. Yeah. Okay. Okay, what else? We don't need this for now. Don't need this, don't need this. Yeah, I think we're good to go. So let's do make. Yep, there you go. I think we should also make a run. I don't want to type out these two things all the time. All right. So we have something called run, right? And it depends on binary. Okay, what we do is we call the binary. I think this should be enough. So make clean, make, and make run. Perfect. Make clean, make run. Yeah, perfect. Cool. This is good enough. We have this. Then what else? Gotta go, man. You're lucky you get to live alone. I'm not alone. I'm living with my partner. I'm not alone. This is interesting. Then we have directory, which is tests. Right? Yeah. And we'll make a file, test. Make a file, test. C. And then we do whatever we want here. Cool. Okay, it could not find. What could it not? It could not find the. Of course, no main function. All right. So first. Perfect. Alright, Thorfinn. Bye bye. You have a good day. Good night. Cool. So we are done with setting up our project. One more thing. I see. Your mother's okay. Mother's screaming at you. I thought you were in college though. Do you still live with your parents? Alright, let's see. We'll look into it. Way to work it in it. fuck? Using master, this is what I wanted to do. Actually, I'll just do this. Alright, man. Uh, I'll see you tomorrow. Alright, till then, bye bye. I will probably write something today. I'll probably implement the entire child process thing. But other than that, I have no plans. So, cool. Off you go. Bye bye. Alice is a built-in, correct. What about CD? CD is also built-in. Good night. Good night, Thorfinn. Actually, go and pee. Alright. Party's back. What was this guy talking about though? What is RC? No idea. That is, see, he describes a very simple flow though. Start up the shell. That is in itself very complicated because first you load up all the environment variables. Then you have to make it available to all the child processes that you spawn. Right? Then you also have your bash RC or whatever RC files, and have to load them up as well. And then you start giving user the prompt. Wait for user input, parse user input. Now this parsing, right, again, it's extremely crazy unless he has other parts to this series. And oh okay, he does. Sorry Indradhanush Gupta, I judged you, did not know your game. All right. Okay, cool. Let's read upon what you were saying. Important piece of all this is through process, correct? The shell is the parent process, correct? This is the main thread of our program, which is waiting for user input, correct? Sure. However, we cannot execute the command in the main, perfect, yes, whatever. To be able to avoid this, we use a system called fork. I thought I understood fork. Yeah, it duplicates your current process and spawns it as another process, which the current process is a parent of. Yeah. Okay, then we'll not look at the code though. Feel like that creates a bias. The fork system call returns twice, one for each process. Yeah. This sound counterintuitive at first. No, because you fork it returns to the parent as the child process, and to the child process it returns something else. By invoking fork, we are creating a new branch in our program, correct? Yes, fork creates a copy of the current process and creates a new one, correct? This is fork. Okay, not this fork probably. Must be one entry for it, come on. Okay, let's try the third. What does it say? No, but these are not the things I'm talking about though. Yeah, see also fork 2. There's no fork 2. There's no fork 2, buddy. I don't know what you're talking about. Is it a man? That would be crazy. Let's fucking go. Okay. Is there a help? No. Show me the main pages. Man to fork. Why do I not have this fucking thing on my computer? No entry for fork in section 2 of the manual. How is that possible? How is that possible? How is that possible? Oh, I don't have. Okay, got it. Of course. Sudo. Yeah. Sure, buddy. Yeah, so what does it install really? Perfect. Thank you, God. Okay, cool. So 4 creates a new process by duplicating the child calling process. Okay. This refers to a child process and the parent process on its separate memory space. At the time of 4, both memory spaces have the same content. Correct. Except for the following points, yes. Child has its own process ID and this PID does not match the ID of any existing process group or session. Okay. The child's parent process ID is the same as parent's process ID. Okay, that makes sense. Child does not inherit its parents' memory locks. Makes sense. Process resources utilization and CPU time counter are reset to 0 in the child. Makes sense. Child set of pending signals is initially empty. Makes sense again. Child does not inherit semaphore adjustments from its parent. No idea what that implies. The child does not inherit process of associated records. Timers from its parents. Okay, cool. Okay, Linux specific things. I see. Okay. Okay, makes sense. Alright, okay, makes sense. Interesting. Okay, cool. I think we can move on. Are there any examples now? The PID of the child process is returned in the parent, correct? And 0 is returned. Yes, this. So that's how both the programs know whether they are the children or if they are the parent. So shell can then continue the execution. Makes sense. Okay. signal is sick child, and you ignore it. Okay, makes sense. PID is fork in case of -1, fork failed in case of 0, puts child exiting, flush the standard out and exit. Then for default, which is PID of the child, I see. Alright, okay, makes sense. So let's see. Let's try to write a very naive implementation. Okay, so for that we have something called, let's first print out a nice hello world message. Okay, so then after that what you do is you loop this. Alright, so while true, and for while true we have to include, but why bother? We can just write for, yeah, something like this. Then what do? We get a line by the user. Alright. I mean, I think the easiest way that I know of on top of my head is maybe something like this. I don't know, I'm just writing things for now. So let's see, we have okay, so we put something first on our let's see this on our standard out. Something like this. Then flush out, std out. Yeah. Let's do something akin to read line. Nope. Make a read line. Alright. So something like chart pointer read line. Right? Let's say it takes a 5 pointer, something like this. Yeah, and then we will use it here. Yeah, makes sense. We will then do something like this. Alright, let's implement this now. So first we have a very important file that we forgot to add to our let's say Clang format. Yeah, and based on style LLVM, and of course perfect, cool. Alright. So ultimately it returns this line. Yeah. So we have line already. Interesting. What is the signature? We take a line pointer. We take a size. Okay, we take a size pointer. So it tells us the size. Ah, got it. So what was the size t, right? So we can do something like size, right, and make it 0. Then we can pass it here, something like this. Then it wants us to give it a stream. So our stream is stdin. Okay, what have I done wrong? Incompatible pointer types passing char pointer. Why though? It needs a pointer to a char. It needs a pointer to, okay. Got it. So something like this would work. Yes, perfect. What else? I see. Okay. So is there something I should be wary of? There's something I should be wary of. Scroll down here. Yeah, let's see. Yeah, perfect. So they allocate the buffer for us. Perfect. Yeah. Correct. It does, yeah, it even takes care of the thing. Then it changes the error number, I think. Yes. So since no one is watching the stream, I think I might as well do this. How do I resize? Increase width. How do I decrease width? Okay. How do I keep doing it? 5, 10, 100. Okay, that's not what I wanted. 20. How do I increase width? Of course. Yeah, this is good enough. Okay, so what I want to do is man get like this. Okay, perfect. I just want to see how they free it though, or if they don't. So you have to do it yourself. What? Yeah, so we can't pass we have to pass the responsibility of freeing this, right? So we'll have to return the line, and then the caller, got it. So we get the line, let's try to print it. Right, so we have flushed, and then maybe this. Something like new line. Take the string, and the string will be line itself. And then what? Then we create what did I do wrong? So I'm taking this, taking a pointer and freeing it, right? Call to standard library for it. Okay. Standard library, got it. Alright. So this should be good enough for now. And then we'll have to add an installer. I also need to do something about my problem. So expand then shift width is already there, tab stop is there, soft tab stop is there, auto indent not there, right? Nope. So auto indent is true. Then what? Smart indent. Right? Then what? Let's see if this fixes it for us. Okay, beautiful. Now let's see. Cool. So we have this. Let's try to run it. Ah, see, perfect. So flushing already gives us a new line. Okay, perfect. Alright, so we don't need this. So if we run it, hello. Yeah, perfect. Cool. This is good enough. Okay, so what we do is okay, let's see. We have to yeah, wait a minute. So does that mean yeah, okay, they also have it. So yeah, I want cache and build to not be included. We have plan format, getting node, compile commands, make file means and tests. Okay. Then we have in git commit, we say first commit or we can make it proper init set up echo ribbon. Cool, this looks good. Alright, perfect, cool. So let's see. We have read line, whatever. So cool. Now, before I move forward with this, I need to actually handle things like, for example, errors and all, right? Um, so, what errors did we see? Let's see, man get line. Yeah, if line pointer is eternal, this buffer should be freed by the user program even if getLine failed. Got it. Okay. Alternatively, before calling getLine, line pointer can contain a pointer to malloc allocated buffer. Okay, this is not what we're doing. Okay, fine. Otherwise, we'll call real alloc anyway. In either case, I'm successful line pointer. Alright. Alright. On success, you will return the number of characters, red. Okay. At the EOF, it will return -1. On error, both functions return -1 with the file stream error indicator set. Okay, correct. So nothing too fancy. Right, what we can do is first, right, then if n is less than 0, then we do what? Then we do we free the line, right? And then we return null. Correct. Right, this is what we should do. Yeah. Cool, okay. Yeah, looks good. So we have this. Let's forget about this now. Let's move on. So we can either work on built-ins, right? Or we can work on maybe spawning processes. What else can we do right now in 20 minutes? Maybe we can tokenize. We'll need tokens because we need to tokenize the input because users might escape from this, right, and then enter a new line, or yeah, I think this is one example. So anyway, okay. our issue, we can actually spawn a process maybe. Should be able to run something. Ooh. Okay, how do I use? That is crazy. How do you move around? I see. This is a game changer. So that with damn fuck. Okay. Damn. Anyway. Okay. So also we need to implement something like a vector. So let's do that. string directly, right? Okay, then maybe the size of it, and then capacity. Yeah. Then we of course have to initialize. Can I move it to its own library? I'll do that later. Once I'm done writing the code for it. We need this because we will tokenize the inputs that are coming, and it will be really useful if we already have a string vector. So what we can do is we can do int string vector init. So what will it take? It will take a pointer, and then we'll initialize it. So capacity is 0, size is 0, and the string is null. Yeah, makes sense. Then we have to do the opposite of it. String with so string point to the vector. Now what I can do is, if it is already null, so there is no point freeing it, so we just return. We'll have to go to each element of the vector and free it. So, and then free the internal array as well, because we're allocating 2 times. I mean, we're allocating multiple times. You'll see. Okay. So first, let's say I is going through the entire size of it and freeing everything. So we have we free think about it. What is so a string is a char pointer. So it's a pointer to a char pointer. It can hold multiple points, right? So you can't call it string. You can call it this maybe. An internal array. So what you do is you free every element of the internal array first, then you free the pointer to the char pointer. So something like this. Yeah. What else? You also save view. So see size. Okay, resistance. Let's see. So now we have to push into this. So for that, we can have a okay. So we can have a push. So same thing. String vec push. First it will take a vector. So vector and the string itself. They call it as what else? So if vector size is more than so let's say if a vector is of size 2 and sorry the capacity of a vector of capacity 2 with the size of 1, then we have to check if this is greater than, because this is 1 so this means 2, if it is greater than the capacity then okay. Right. Then you have to increase the capacity, right? So what we'll do is we'll do capacity something like this. So if we had capacity, we take the capacity, multiply it twice and let's double it. Otherwise it goes to 8, right? Then we take the I have to read about this actually. So what does alloc do? Interesting. I see, of course. I'm using yeah, there we go. Yeah, I think we have to use realloc. Realloc. The realloc function changes the size of memory block pointed to by 2 to size bytes. Yeah, perfect. The content of the memory will be unchanged in the range from the start to the region of perfect. If the new size is larger than old size, the added memory will not be initialized. Okay, cool. If P is null, what is this? Okay, if P is null, then the call is equivalent to mal. Perfect. Okay, beautiful. If size is equal to 0, then the call will be equivalent to unless P is null, it must have been returned by an earlier call to malloc. Okay, makes sense. I mean, I would want it to be open. Yeah. So, what does it return? Yeah, okay. So, it will return to us the new array, if I'm not wrong. So, realloc, take the old one, right, and increase the capacity to hold strings. So take the new capacity multiplied by the size of chart pointer, if I'm not wrong. Right? Yep, okay, there you go. And then if you don't return me anything, then return false. Then what you do is you take the array and make it human. Okay, makes sense. What else? You have to increase the capacity to new capacity. So take and if all this is done, then you take the array, increase this, basically do something like so in an empty vector it is 0 and we want it to be 0. Yeah, so we'll take it to n and then something like this. Is it fun? Oh yeah, of course, I mean yeah, and then something like this, and then you return true. Perfect. this code we have to be very wary of. Above my pay grade. Anyway, makes sense to me though. Alright, so we have a vector. We can actually take all of this and yeah, so what we can do is make an include. Right, then go to file, take all this, and paste it here. Right, this will stay here. Okay, so we include standard library, standard bool, and we are good to go. Okay, of course, something like this. Okay. Then what? So we have it here, perfect. Cool. Then we have to do something with our make file, and we have to create another file called rec.h. Oh brother. What file did I make? I remove it. It reverse the order. How do I? Capital. Let's see. So I delete this. Should work. It will work in a second. Go here. Make file. We say. What do we say? Let's try to add this. So rec.c. Same here. Then we have I think they called lips or something, which is just I include something like this, and then it comes in handy while compiling. Yeah, C flags. No. C flags, ready flags. Think ready flags. Something like this. So now what happens when we do a make clean and make? Okay, can't find it. Why can't he find it? Fuck. Ah, something seems wrong here. See? Build object. No such file or directory. Okay, we can take in reference of Pare. If you can reach it. Yeah, make file. Wait, what the fuck are we doing? It's alright. Neowin can run Neowin, it's okay. Anyway, what were we doing? Server. There were C flags. Okay. Come in handy when compiling. Got it. And linking. Ah, I see. So yeah. So we need to define it as C flags. Okay, then if I do make, should compile, right? And now I want to lead stream by adding some tests for it. Do we have assert in C? Assert. Yeah, we have to just add. Okay. An assert test is more than enough for us, I feel. do an init. And then we assert the following. First, array should be this. Okay. So we should print out something like test passed. So something like okay. So we will create something called okay. Actually, we can just print out I don't want libraries though. Okay, alright. So fprint stdout let's call it 100%. Seems more professional. No? Alright, okay, looks good to me. So make test. Alright, perfect. Cool. So let's do get status. We want to include everything. Added implementation of directory. Added okay, looks good. Fine. So our task for tomorrow. Do we have taskmaster? No, we don't. So query external repositories about task warrior. Okay, so we don't have task warrior. Let's make sure task warrior. GNU? No. Void. Linux. Linux. Void Linux. Man, I should have just googled it. Will this write tasks for normal people? Okay, so first task that we have is to given node okay, then we have let's see. Make tokenizer for user input, then make a few built-ins. I'm thinking what built-in can we make? Let's do ls. Make ls. Yeah, this is enough. Perfect. Sure. Alright, I think that is it. We finished stream on time, guys. Let's go. Alright, bye to no viewer of mine. Man, I must suck so bad. It's crazy. Anyway, bye.